we've talked a lot about the CDM, and the CDM is kind of the foundation of the architecture in a way. It may not be traditionally considered the software stack to just look at the database and say it's part of the architecture, but I feel like the data architecture is a fundamental part of the overall OHDSI architecture. And so I wanted to talk a little bit about this. We're not going to get into too much detail, but let's start with what the CDM is, right? So the OMOP Common Data Model, as it was originally defined, is a data model to support the storage of patient-level data. It currently is in the version 5 spec, although it's not 5.0. It's, I think there's a 5.1 and a 5.2 and a 5.2.1. But so it's evolving. There is work underway for a 6.0. It has come a long way. It supports pretty much any source of patient-level data that I have seen to this point. It does so very well in a majority of cases. And so anytime it doesn't, there is a very active working group who is there to support whatever changes we need to make in order to adapt it. We don't lose data when we convert from our source data sets. That is something that I hear sometimes. We have written papers and published them. We have shown posters and demos about the losslessness of data in the conversion process. So if anyone has that particular fear, hopefully it's a little bit alleviated. This CDM data set has a few different pieces to it, or the CDM database has a few different pieces that I want to make sure people are aware of. The first is that it has the schema for the storage of patient-level data, but it also has vocabulary content and a schema for the OMOP Common Data Model vocabulary, which is the way in which we standardize our data, and it is a way in which we are able to navigate through the data and associate all of the records that are in it with different medical concepts, different medical ontologies, terminologies, and taxonomies. I think those last three words all mean the same thing. This is blurry, and I didn't care because I don't want to get into the detail of the data model. Suffice to say that you have a person-centric model with condition occurrence and procedure occurrence and drug exposures, observations, observation periods, death records, note records, all of this stuff. You also have your vocabulary tables. That's what the schema looks like. When you load your CDM and you convert your data set into the CDM format, you do so on the basis of the current vocabulary that you are using. Here's a fun one. The CDM vocabulary we refer to often, but not many people necessarily get it sometimes when we say the CDM vocabulary. What do we really mean? Well, there's a set of content you could download off of websites. Athena is the current and new version of a tool to get the vocabulary content. That means you're getting CSV files that have the different code sets and terminologies and the relationships between each other that have been curated and mapped, some sourced from the National Institute of Health Unified Medical Language System, UMLS, or Metathesaurus, some curated from other sources, all part of a very intricate build process that is open sourced and published of how we create our vocabularies. So when we say the CDM vocabulary, that's what we're talking about. Now, as part of that content goes into a CDM. It sits inside tables inside the CDM schema. Okay? So the CDM schema has a set of tables that contain the content of the CDM vocabulary. The real fun comes in one of those tables is named vocabulary. It contains a list of all the vocabularies that we contain in the vocabulary table and within the vocabulary content of the OMOP Common Data Model vocabulary. Okay? So probably not the best naming convention that we adopted there. But I'm actually going to pause. Is there any questions about what the vocabulary is and how it plays a role in the CDM?
case from Boko. I'm the CEO of the Hive. And so in the Hive we have multiple open source groups of software developers and data scientists. And one group is working with OHDSI, another is working with ITB Transmart, another working with Radar, one with CBI Portal for Cancer Genomics, and then we have a group with Fair Data Teams. And I asked Wednesday already a question in the meeting about ITB versus OMO. So what I always say about these two data models is that it's very easy to convert from OMO to ITB because OMO is much more precise in that it has actually a table for conditions, for procedures, etc., etc. Whereas ITB2 is more flexible because it focuses on the observation facts. Now, potentially in OMO you could also load anything into observation and add your own vocabularies to it. Right? The strength of ITB2 is that you can define your own vocabulary. For example, if you clinical trial, you can find trial arms, or in the Dutch Cancer Registry, we have this whole CDM classification, and then we go into things like tumor staging, the number of cores, results from pathology reports. So, adding your own vocabularies to the OMO CDM. How do you see that? Does it make sense? Should one do that and not do that? That's a question I have.
So should you augment the existing vocabularies with additional vocabularies? Is that a good read on the question?
We had this discussion yesterday in oncology where, okay, there's a lot of structure potentially in oncology, from staging, from pathology, or even from genomics, that you could go ahead and just try to create a number of new tables in the OMO CDM. Yep. Or you could say, well, let's see to what extent we can do vocabularies and fit those in as observations.
Sure.
Maybe you can just speak a bit to that.
I can. All right, so the first thing I'll say is this is my opinion, and being that this is a community-oriented group, it's one opinion among many. So first thing I'll say is that one of the things I hope people understand is that when you convert your data from whatever source system it is into the common data model, that conversion process leverages the vocabulary, right? So if you have ICD-9 codes, or you have ICD-10 codes, or you have READ codes, or you have ATC codes, or ETC codes, or whatever you have in your source system, we map those codes to certain standards within our platform because that's how we map things. That's how we standardize. So our conditions get standardized into the SNOMED vocabulary. Our drugs get standardized to the RX norm vocabulary, right? So the first thing that's important is to make sure that whatever the source system has, we have a way to map it to our vocabularies. That allows us to have that standard and enable a lot of the tools and analysis that we do down the line by applying those standards earlier. In cases like you're describing where we have data that we don't have a specific domain table established for, the historic precedent has been that we add those to the observation table. You are correct in that ITB2, their data model is more of an EAV, like an entity attribute value model. That makes it more flexible, less defined, however you want to look at it. We use the observation table very much in that way. So what we've said is, it is true that we may want to flexibly define a set of conditions, but given that we've been using the condition table in its somewhat current incarnation for a number of years and have been able to do everything we need to do, we feel like having a condition table makes sense. Having a drug exposure table where we know that for drug exposures we want them to have a start date and an end date, that having a defined domain for that makes sense. I guess what I would say is we try to drive our vocabulary and data model on the basis of established use cases. If what you are working in, and if you're working with genomic data or even maybe tumor staging data, you are in a novel space and a new space to the CDM. So the thought would be, yeah, you could put that in the observation table up front when you start, and we could start working on how those vocabularies or what vocabularies we need to include. As the use cases evolve and as they become more stable, the precedent is that we then go and create a new table to store that data specifically. With regard specifically to vocabulary, I know in our environment we actually add some of our own vocabulary information to it. Specifically, source to concept map is one area where you will do that, where your source data is coming in a format that is other than what we have currently in the vocabulary. We'll insert records so that we know how to do our mappings between whatever the source structure is and what the, what we want to map to in SNOMED or ArcStorm or what have you.
Thanks, Ryan. That's a great answer. It's very helpful. Thanks.
Any other questions about, yes?
With vocabularies, if I heard correctly yesterday, there are certain vocabularies that are available but require additional licensing. Where can I get a good perspective on that so I don't step into anything?
Great question. So I believe in the Athena tool, when you go to download them, the vocabularies that do require a license, there's a note. So you'll be able to see that and understand where you need to go to get the license set up. Pet peeve of mine that the coding systems and ontologies that are out there are locked down by licensing. It's one of the things that frustrates me. It's something that I feel like should be open source. It shouldn't be hard to fund the curation of those going forward and make them all available, because right now it just acts as a barrier, right? You have informaticists and data scientists and all of these people who are interested in doing work in this space, and then they're like, sorry, you can't have the CPT code set, or you can't have this code set, or you can't have that code set. But we've decided, a vendor's decided that they're going to use that as their standard, not for bad reason, but now all of a sudden, we have to be really careful and we can't share those things, and that becomes frustrating. But within the tool, we try to point out what are the vocabularies that do have restrictions. In the public instance of the tool set, like if you're browsing vocabulary via Atlas, you won't have access to the licensed terminologies. So we have it pretty well sorted out. It's just not necessarily easy to get it all. We can't facilitate the licenses. Any other questions about vocabs or the CDM? Sorry, go ahead.
I think CDM typically is pretty US-centric in some sense. For instance, Alex knows they don't use it outside the US.
So to date, and in my environment, I have loaded data from Japan, UK, Italy, Germany, and done so successfully. It is true that RX norm as a standard isn't widely used, and I would not, I'm not the person to speak to about why RX norm in particular was adopted as a standard. But I could say that in the cases where we're working with things like ATC, or ICD-10 and how those mappings occur, the mappings are possible and well supported. In terms of that not necessarily being a widely adopted standard internationally, and why we use that for a standard, that's kind of outside my purview.
In the US, there is an external extension that is actually created as specifically to give international matters. Personally, that is good that is can actually answer all the questions that you might have here. Yes, so there is an external extension that was created to essentially fix the problem of external being US focused vocabulary extension. The person that is a part of the team who created an external extension, they continuously curated to bring more international vocabularies in mappings. So I think the user is not extension.
Sorry, what was this app used for?
Sorry, now I cannot hear you.
Well, sorry, I'm not so familiar with this application. What is that called?
Athena. Athena is the application where you can go and download vocabularies from.
Oh, no, oh.
So for the benefit of everyone in the room, there is an application called Athena. Athena is a website you can go to that allows you to access the vocabulary content that we're describing. And so typically you would download that, load that into a database, and then use that as part of your CDM conversion process.
It's a bit difficult to hear, I know.
Sorry. Okay. We'll make Greg speak up.
I have one more question.
Sure.
Have you considered to adopt UMLS instead of creating your own vocabulary sets?
Yes, it was considered whether or not we could just directly use it. At the time, there were vocabularies that were not in UMLS that were required for the work that OMOP originally set out to do. So they decided to augment it with what we have today. There were two problems. One was a number of vocabularies that they wanted to use that weren't there. The other was the update frequency of it at that time was not what they wanted it to be. Now, I may argue that by adopting our own and now having to manage it ourselves, it is more complicated than it might have been at the time to join those working groups and bring them along to the point where we could use them. But there are some very strong opinions in the community that the current vocabulary is appropriate and well established to do what we need. But yes, it was discussed. And if it's something that you feel strongly about and would like to revisit, Christian Reich is definitely the guy to go and talk to about how we use what we have today and how it leverages UMLS, but as you accurately point out, is not purely just a copy of UMLS that we just leverage directly.
Okay. Another question on the standardized vocabularies versus the rest, like the European ones. So when we did some of the European data mapping to establish this true standardized vocabulary, but throughout the OHDSI tool set, these are treated differently, right? So in Atlas, for example, in principle, you only query on the standardized vocabularies, and if you choose so, you can go into the OHDSI. So how do you see that?
So in Atlas, one thing that you could do is browse vocabularies, right? So you can search the vocabulary across any of the vocabularies that are there. You could create concept sets, which include any set of concepts. The standardization really comes into play when you look at what values appear in, for example, in a drug concept ID column, in the drug exposure table. That will always be an RX norm concept because that's the standard it maps to. If your source system that you're loading data into a CDM is coming in something else, which it almost definitely is, then that value would go into your source value column, and the drug concept ID has that. However, the way the vocabulary is established and the way that we process things like a concept set. And so just a little bit of background. There's something called a concept set, which is a group of concepts and some logic. And the logic basically is things like, do I want just this concept or this concept and everything that is considered a descendant of that concept? Right? And so when you're designing a study, you may say, I want to study opioids. Now, there is a classification for opioids in, let's say, the WHO's ATC, which is a drug classification system. You can use that and then say, give me all of its descendants. Before this, what we would do is we would create a list of like 16,000 NDC codes, and then we would use that to define the cohort of people who had been exposed to an opioid. What's the problem with that? Well, the problem is, what was that list? Where did it come from? How was it developed? What was the logic behind the idea of using that list? Especially when you start saying, well, we're going to exclude these 3 or these 6 or something else. So what a concept set gives you as a tool is a way to preserve the logic of what you were thinking when you designed it. So if, in your case, you're using a non-standard vocabulary, but you established relationships in it such that your concepts are descendants of the standard concepts, then selecting the standard concept and saying, I want this and all of its descendants would in fact find or identify the records in whatever your underlying vocabulary was. But most of the tools today require that you are mapping to the standard concepts in order for them to work. However, in things like the Cohort Definition Editor within Atlas, you can in fact specify that you want to identify people based on source values as well. So it's not limited to the standardized concepts, but it is more performant and a little bit more of the structured way that most of the tools function.
I guess an important point about thinking about standardization in terms of vocabularies is that the idea is not to run to a single CDM. So the code that you create needs to, the idea that you can be used to any number of CDMs and the result is data kind of package. So unless you have a standard set of reference data, that's what really vocabularies are, the query will not successfully come back to the list of results set if you run it elsewhere. Even within your specific organization, you might have different data sets and use different reference data when you perform conversion. So that's probably one of the main and fundamental reasons why you need to standardize a certain set of vocabularies, a certain set of concepts within those vocabularies.
Any other questions?
Maybe you talk a little bit about having local, local non-standard codes, so 2 billion. You know, the concept that these over 2 billion are local.
I could talk about that, but I'd feel really bad because we don't really do it anymore. So there used to be some people do it. So there's a little known approach that you could take to kind of operate outside of the, if you want to create your own concept IDs, right? So concept IDs come as part of your download of the vocabulary content. And all of them are under 2 billion, the concept IDs. So if you want to start adding your own concepts to the concept table, the recommendation was add 2 billion and you could have them there and you're not going to overwrite or step on any of the existing concepts.
So you can have your own local concepts and then map them to the standard concepts.
Yes. It's like hacking the CDM. You can, yes.
Useful for survey questions.
Yeah, I mean, what I would suggest is if you are finding yourself in a position where you need to add things to the concept table to do the research that you're doing, by all means, do the research you need to do. However, also communicate that with the vocabulary working group and let's make it part of the standard because you are likely not the only one who has that issue. And that's actually something that I see frequently. Another thing that will frustrate me from time to time is people will see that there's something that they're trying to do that they can't quite do, and they operate under the assumption that this problem is local to them and only them, and it's usually never the case. You know, I've seen instances where people will post on the forums, which we'll get into a little bit later, and like within like 15 minutes, somebody from halfway around the world goes, yeah, I have that problem too. So yes, absolutely, you can do things where you need to add your own concepts. I just really highly recommend that you try to bring it back into the community discussion at some point because that's how some of the best innovations have taken place is, you know, 2 or 3 people all agree like, oh yeah, I have that problem, then suddenly it's part of the standard, and then suddenly the next person who comes in doesn't have to deal with that.
So a little specifically to that comment, there's a push within the vocabulary workspace to get survey information into it as well. So if you'd like to, you know, kind of take part, that'd be a great idea as well.
Lee, you decide yourself onto another working group. Or, that's great.
I'm very.
Question?
Maybe just as an anecdote, this is what we did with procedure codes in Germany. So we have our own vocabulary. There is no mapping yet to anything which is available already in Athena. Some 50,000 concepts, we were not able to do it in the brief time. So we imported them as our own concepts. We imported the data according to that, breaking for now the compatibility, making it standard concepts so we can search for them. And as soon as the mapping will be established, what we did with ICD-10, the German modification, we have to validate it and then we will give this back to the community.
Excellent. Great. Any other questions? There's often a lot of discussion around vocab because there is a lot going on there, and that's why there's like a 8-hour tutorial just on vocab and CDM. But hopefully we have a good idea of how it fits within the overall architecture. The Web API. So we have a service layer called the Web API. It is written in Java. It is a set of REST-based web services. It has a job manager that allows us to do long-running asynchronous jobs like queries that do cohort characterization or generate cohorts across different CDM databases. It leverages a library called SQL Render. SQL Render is how we translate a SQL query from one dialect to another. A dialect meaning, you know, whether it's the T-SQL of the Microsoft SQL Server platform or PL SQL of Oracle or an ANSI standard of some type across any of the other platforms. It has a mechanism for security leveraging Apache Shiro. Not necessarily run in all environments, but it is there and has been turned on by several groups that are using that. It can be launched via Spring Boot for those who are at that level and want and care. It uses Spring Batch as its job manager. This is a very kind of non-functional view of what the Web API is. We'll see a little bit more about how the Web API plays a role as we talk about some of the other applications. But suffice to say, the reason the Web API exists is because we wanted to try to facilitate access to these CDMs and capture, as I pointed out earlier, that idea of some individual contributor who had created some analysis. The Web API allows you to run some of those standard analyses that have been built into it as part of a broader framework that allows you to perform research. And I'll do a little bit of a quick demo of Atlas, and we can see and understand how it all works. Atlas is a front end for this Web API. It is a web client. It's based on HTML, CSS, JavaScript. It uses Knockout as a templating engine. It is what uses the Web API. Now, something that often gets confused, and I try my best to be clear about it, is Atlas and the things that Atlas does are only exposing the Web API and what the Web API does. Okay, so if you're ever looking at something and you're like, I really wish my tool had what was there in Atlas, then it's likely that you can just use the Web API and integrate that into your tool. You will see work that's been done by Greg and his team on Arachne where it directly talks to the Web API. It doesn't talk to Atlas, right? The Web API is the service layer that allows you to communicate and work with things across the architecture within the Odyssey stack. Atlas is just one client that can be used to do that. There are people who are using R to talk to the Web API to do things. Okay? It is not limited to Atlas, and Atlas should not be the thing you look at and say, this contains all the functionality. It's really just exposing what the Web API provides. So in my current screen sharing state, I'm going to bounce out to Atlas. How many people, by a raise of hands, or actually like half of you have Atlas deployed, So how many of you are like, I'm super comfortable, don't show me Atlas, I know everything about it? All right, so like mostly nobody. I'm not going to go through tons of Atlas just because it'll screw up my demos. But I'll go down the left menu and just talk about briefly what's in Atlas, why it's in Atlas, and hopefully do name dropping of lots of Greek gods that then clears up maybe some things or informs you about some of the history within OMOP and now Odyssey. Okay, so Atlas, it stands for something. I forget what it stood for, but it's an acronym like everything else in Odyssey. But it is the web application that has become the central point of our tool integration. And by integration, I mean we didn't start out saying, let's build one central tool to do everything we want to try to do. We actually started out quite the opposite. We started out by saying, we're all working on really hard problems. Let's focus on delivering solutions to our hard problems, and let's do that independently so that we're not hamstrung by trying to boil the ocean and do everything at once. So we actually started out with CDM, which was an editor for defining cohorts and a specification for how those cohorts could then be generated against databases. We started out with Hermes, which was a vocabulary exploration tool. We started out with Calypso, which was a feasibility analysis tool for cohorts. We started out with Heracles, which was a cohort characterization tool. And if you go into the GitHub repos, you'll see all these older things that we used to do as independent tools, and now we have tried to bring them together. And we've done that through Atlas. Atlas was a project that I initiated a long time ago. It's like any parent. It's an ugly baby. It has lots of flaws. It's based on old grumpy man technologies that are no longer current or cool. But it is, in fact, just where we're at today. So what has gone into it? Data sources. The data source tab provides reporting features for high-level database characterization of CDMs. Those reports are what were originally developed and deployed as Achilles. Achilles was the first tool that was released by Odyssey. It contained two pieces. One was the Achilles R package. The Achilles R package generates high-level database characterization and statistics on an overall CDM. It also had Achilles Web, which was a website that allowed you to view all of those statistics. The Achilles R package has a feature that allows you to generate statistics that get written into a database table in your CDM. And then it has a feature that allows you to export those statistics to JSON files. The original Achilles website would read the JSON files that you exported from your R after you did your analysis. Recently, through contributions from Columbia, we now have a web service layer that exposes those statistics that are stored in the CDM database Achilles results table and allows you to view them directly from within the Atlas web application. So Atlas now has a way to show the old Achilles reports. We based that entire reporting feature off of the work of the Achilles working group and the Achilles packages. So we just brought that in to Atlas. The vocabulary tab allows you to search the vocabulary. This was originally done through an application called Hermes. That application actually was somewhat the foundation of what Atlas has taken on. So we took the original Hermes code base and just kind of stuck Atlas on it and then changed some things up, and it grew from there. Concept sets, as I mentioned, are ways to define groups of concepts and allow you to define those through logic of saying, I want this concept and all of its descendants. You create them through kind of a shopping cart experience. Cohorts are the way in which we define groups of people that we want to study. That comes from the original CDM project. And that cohort definition editor has evolved a lot over the last few years, and it is now embedded into Atlas as a way to define your cohorts. It will use concept sets to help you identify people. And the cohort definition editor we could spend a week on all by itself to learn how to use all of its features. Incidence rates is work that was originally done in another working group, but allows you to calculate incidence rates for different defined sets of concepts for a cohort that you had defined. Profiles allows you to view individual patient profiles through a viewer that was developed through a separate working group. This allows you to look at an individual and all the data related to that one person, facilitated through Atlas. Estimation allows you to go and develop a population level effect estimation specification, defining a treatment group, defining a comparator group, and defining an outcome and a time at risk to actually generate hazard ratios. That specification editor is here. I'm actually using a localhost old version. That's odd. Usually localhost is the best version of anything. But the current build actually has the prediction module in it, which allows you to define a patient-level prediction specification within Atlas. Both the estimation and the prediction modules, when you have finished defining them, allow you to export the R code required to run the full study. Jobs and configuration are boring. Feedback is a link to the GitHub issues list. As I said, I don't want to spend a ton of time digging into Atlas and Atlas functionality because I do want to try to keep this broadly around the architecture and how everything works. But I'll pause here if there's any questions about Atlas or the web API and the way they play a role within the architecture.
Two quick questions since we talked about Achilles. So one, the Achilles interface now, is that the data source?
Yes.
And two, would you still run the R packages to populate the tables
Yes.
in the database?
Yes. And unfortunately, there's no more transparent way to know that you have to do that step. Like a wish list item that I've heard is, it would be great if I was in Atlas and I saw that I had a CDM that didn't have the Achilles results generated. I could hit a button and it would go and generate it. We don't have that facility today. So yes, you would go and run the R package manually. It would generate, create, and populate the Achilles results table within the CDM.
Just one quick question in relation to compatibility or other rules on Windows. On the back end, I used to be a back end developer in North, and I was trying to set this up, set up the web API on a Windows laptop talking to an Oracle database. And when I got to talk about things like mobile and things like that, I was questioned by the window. And I was absolutely ecstatic here. I was hitting the VM, this, and to be able to interact with that. Does that configuration, does it comfortably sit with Windows and Oracle? Am I beating my head up a brick wall, or should I actually try and continue to pursue that?
Does setting up the web API on a Windows machine pointing at an Oracle backend work? Yes. So one of the admitted challenges of our architecture is setting it up. And we have plans, the best laid plans, and solutions that we're trying to pursue to make it easier. But yes, I have a slide later, but I'll spoil it now. Basically, to get the architecture up and running with the web API and Atlas, you have to get the bits for Atlas, host them in some kind of a web server, Tomcat, IIS, or otherwise, and then configure one of the JavaScript files in there to point at your web API endpoint. To have your web API endpoint up and running, you have to download the bits. You have to have Maven. You have to run a Maven build after populating settings in a settings.xml file to tell it what drivers you want to use, to tell it what your connection string information is, to give it another connection string for the configuration database, what we lovingly call the Odyssey schema. You have to then, once you've done that configuration in the XML file, you then have to build the web API. You then have to deploy the web API to a container for the WAR like Tomcat. Now you have your web API up and running.
So all that I lived through that entire experience, in fairness, the instructions are quite good, I think, and not being that familiar with all the HTML components. It's just when it starts near the end, it starts producing errors, which mean absolutely nothing, I suspect, to most people. And that's where I was struggling. And then it transpired that other people had some similar problem. So I'm not going to raise it. I was curious as to.
So it is my lifelong goal to make sure everyone can run the web API. So by all means, let me know where you're at. And this is another place where the forums are useful. But like where I stopped there, that's like halfway through what you need to do to get it up and running.
That's kind of where I stopped.
Yeah, there's more. Sadly, there's more.
Before I forget, one small thing. You use port 8053 for the repository in order to compile the web API. And this is not allowed, at least in German university hospitals, in the firewall.
So the way the compiler does the build, it actually links to a port for, I guess, debugging, 8053. Oh, okay. And you can't do it. I've had people where they're trying to deploy in an environment that's offline. Like they don't have internet access at all. And they're like, how do I do this? I was like, you don't. You sneakernet, right? Does everybody know sneakernet? Am I the only? Yeah, sneakernet? Sneakernet is where you take a USB drive, you plug it into the computer that you can access the internet on, you unplug it while wearing your sneakers, you walk across the room to the other machine that doesn't have internet access, and you plug it in. That's the sneakernet. No? Okay. The jokes don't get better. Yes?
So when our web API up and running, the reason that our web API is installed because that is requirement for access to get started. So my question is, can you give us an example how to use web API for some other research project or whatever?
Sure. So if I understood the question correctly, it's many people have web API up and running to support Atlas, so you could run Atlas. What is a use case for the web API other than Atlas?
Yes.
Okay. So one of the things we do within our environment is all of our statistical analyses are performed in R. So we will be in R Studio. And you can actually talk to the web API and ask it for a cohort definition directly from within R. You could ask it for the cohort definition. You could say, hey, I want to run this query against an Oracle database. Please, you could ask the web API, please convert this SQL statement based on this cohort definition to Oracle, and then let me run it. And then you could run the query directly in R. We use it for things like in a population level effect estimation, you may need to specify a group of covariates that you want to exclude from your study. In order to do that, you could either have a hard-coded list in a file, or you could actually talk to the web API and say, please resolve for me all concepts that are in this concept set, and it'll send you back the list of all the concept sets. So those are two ways that I'm familiar with how we will use the web API outside of Atlas. Any other questions, web API or Atlas?
Yeah, I'm giving you a hard time with questions, Frank, but this one's about performance. Mm-hmm. So we were looking at making Atlas a bit more snappier, but there's a lot of stages now. It can be in your database, it can be web API. Specifically, how fast you get a result when you search, for example, for vocabulary terms. Mm-hmm. So, yeah. Oh.
Yeah, if you use Frank's machine, then it runs really fast.
So your question is, in terms of performance, what can we do in general? Or it's like you were just bringing up I swear I did not pay this man. Later today, I'm going to be doing a demo of a small branch that I'm working on called Helios, specifically to address performance concerns with search. So, but I don't want to cut you off there. Was there anything else, or just specifically like performance with vocabulary or other things as well?
No, that was specific
That was a specific one? So now you'll be looking forward to Helios. Yep, so I won't talk more about that now. Don't want to steal my own thunder. Any other questions, Web API or Atlas?
Do you want to talk about the ability to export several file? I'm sure everyone's aware of it.
Sure. So one of the things that you can do that Leah's brought up is one organization can create a cohort definition. We actually do this in some of the collaboration work we do with Columbia, where we will define a cohort in our environment, and then you could export the JSON file, which is how we serialize that definition, and send it to someone else, and they could then import that cohort definition. You could either do that through Atlas or through the Web API directly. So it is another way to allow you to share some components of a study design with other collaborators. Granted, it's not the easiest way. Actually, Greg will show some more fun ways later today.
Just along that same line, since a lot of people build cohort generation tools,
Yeah.
is there a spec for JSON? Did you pay?
I didn't pay this gentleman either. No. Well, yes and no. There's not a published spec. There is a spec. One of the topics of our architecture calls recently has been our failings, my failings, because I am the benevolent dictator. And one of those failings is that in our rush to develop implementations of tools, we have done a poor job of providing documentation or publishing our specifications. So we're actually adopting an approach closer to how Apache works, where we will, for things going forward, start by publishing a specification for things that we want to do, and then create reference implementations based on the specification. Before we create a new specification, however, we have committed to creating specification for our existing things, notably concept sets, where that specification is, while we could discuss, and I hope to at least today, and debate the way in which we publish these specs, concept sets and cohort definitions are the first two that I really feel like we need to address. Concept sets, not so much on their own, because they're really used within cohort definitions, and they're embedded within the cohort definition spec, so they're going to be important there. But to your point, I know of at least half a dozen different cohort definition tools. I know of one that actually creates the Atlas or the Web API Odyssey cohort definition spec. And I don't know how they did it, because we don't have that spec published. I mean, I guess you could reverse engineer it, and maybe that's what they did, and kudos to them. But yeah, that is a shortcoming and something we intend to rectify.
And I think it's really actually closely relevant to this question about Web API, what else you can do. You can only use an API if you're aware of the specification that it implements. And so later today in the demo, we'll show you a working solution of how you can essentially reuse functions from the Web API to import cohort definitions, so even more complicated population level effect estimation studies into Arachne, and then utilize it from Arachne by executing those studies across multiple data nodes. So we'll show you an example of what we've done today, but again, it would be a good discussion of what we need to do to document a spec moving forward and make it more transparent to others to reuse.
We do have we do have documentation of the API that's automatically generated by a utility called Mirdot, and so that's out there. So the broad API documentation is available, but that doesn't replace the need for a specification document up front to tell you what it was we were intending to create when we did it. I guess two reasons. One, you know, a lot of the development has happened at Jensen, not exclusively, not anywhere close to exclusively, but I know we, at least I can admit, have failed to deliver good documentation or specifications for things a lot of the time, because it's like, go do this now, and the first thing we're not thinking, let's design a spec first and publish it. We're just like, oh God, we need to get this finished because our boss said so. Our boss being Patrick. And so we rush to implementation frequently. So hopefully when we you know, going forward, we're working a little bit more in a structured way where we're able to do the specification work first. The other problem, other than just under the lash of another dictator, is we didn't necessarily have this kind of a community when we started, right? There wasn't a group of people being like, hey, where's the spec for this? There was nobody else necessarily working with us outside of a very small group as OHDSI was initiated. So it's growing pains is the way I look at it. Things we did poorly, both because we didn't have the time, we weren't aware enough of what we would need to do to support a community. And now as the community is growing, we want to try to be more transparent about what we're intending to do, but also publishing it as specification so everyone can contribute and or have their own implementations outside of whichever one we come up with. Okay. I'm going to go through this slide just now as trying to get to the point where we started off saying we were going to talk about the overall architecture or the architecture overview. And now this should give you a good picture. And hopefully you could look at this and recognize everything here and what it is mostly. I think I've at least said all of these things now. Maybe. So if we take from the stack top down, you'll see that you could have a client to the OHDSI stack, or Atlas as we have today as the primary one. It talks to the web API. The web API is capable of talking to all of the standardized CDM databases that are configured in your environment. So you could have one CDM, you could have 16 CDMs. You only need one installation of the web API and one installation of Atlas to work with all of them. Question?
Can those 16 be different in one SQL server?
Yes.
So
So, correct, yes. So the web API has a, you configure your sources. Your sources can be any of the relational database platforms that we support. In the Janssen environment, we have CDM sitting in Redshift in the Amazon cloud. We have CDM sitting on the Microsoft Parallel Data Warehouse on an internal infrastructure. We have test ones sitting in Postgres. So yes.
So do we have to provide like an connection string for all the databases?
Yes. When you configure, we stopped at the you compiled Maven, now you have a WAR to deploy. One of the next steps is configuring a set of tables that are created automatically by a system called Flyway upon the startup of the web API. One of those tables is called the source table. The source table is where you define each data source that you have in your environment, and as part of that table you provide the connection string. It's not encrypted. Okay, so you are connecting to one or more CDMs. There's something called the OHDSI repository, or the OHDSI schema, or it's a configuration database. It's that thing I just mentioned that's created by the thing called Flyway when you start your web API. It's not my favorite. But it does create and manage upgrades of the schema over time for us. That repository can sit in, it doesn't have to sit in the same SQL relational environment as your CDMs. It can be completely standalone. It is essentially storing metadata and configuration information. Your cohort definitions, those specifications are stored there. Your concept set specifications are stored there. When you're in Atlas and you search for a term within the vocabulary browser, it's querying a vocabulary not from there, but from one of your CDMs or another identified vocabulary service. When you generate a cohort definition, you load the cohort definition from your OHDSI repository, and then you run it against one of your CDMs. Okay? So just so you understand, there's a separate database that's independent from all of your CDMs where all that's being managed.
So just to clarify, so if you added another source or something in your sources changes, like a password, you don't have to reconfigure the or recompile the Maven file. Basically, change it within the OHDSI repository.
Yes. There is currently no admin interface for adding or managing sources within Atlas. There is currently no web API interface for managing sources. It is a manual operation you have to run on the table, but you don't have to recompile the web API itself. Little known fact, after you insert some records, those sources are cached. So there's a refresh route on the source web API that allows you to refresh and then update your client. Well, it updates your web API. Atlas also caches your sources, and on the configuration tab, there's a button that allows you to clear your cache to pick up new sources. This allows you to do some nice things, namely, you can add a new source to your installation, and then people who know that you've done that can clear their cache and then test that new CDM, and then you just have to inform your broader community of who you support that that data source is there so they could clear. Otherwise, the Atlas cache clears every 24 hours by itself, and then people will pick it up the next day. Yes?
Was that cache button in 2.1 or was it just released in 2.2?
What's that, the cache clear?
Yeah.
I think it was released in 2.2.
2.2, okay. And then I had a question. There was a poster yesterday that was talking about Query Garden as a potential replacement for SQL render. Did you get to see that? And what are your
I did.
What are your thoughts on that?
So the fundamental problem with Query Garden is that Query Garden itself doesn't address the issue of translation at all. SQL render does two things. Sorry while I try to log back in. SQL render has two functions on it, and again, our naming may not be the best. One function of the SQL render library is called SQL render, or render SQL, and that will perform replacement of parameters into a template. The other feature of SQL render is called translate SQL, and that will translate from what we call AutoSQL, otherwise known as essentially T-SQL with some tokens in it, to whatever other dialect you're trying to translate to. So while I liked what they were doing with Query Garden, it doesn't actually do the translation, and what we would have to do is create templates for every relational database platform that we support in order to have support across all of the different platforms that we allow people to use. Gotcha. Yes?
Does this infrastructure track which ones are populated in different databases? Like you'll often have, depending on the source of the data, you may have some columns that just don't, you don't put anything in. Does this track that in any way?
So the question is, if I understand it, within the architecture, is there a way for you to understand whether or not certain areas of a CDM are populated? Okay. So there's two ways. The primary way, the other is a shameless plug. The primary way is using Achilles. A series of reports are generated. Those reports will, as you go through them, they will show you what areas of the CDM are populated or not. In particular, there's one called a data density report. And the data density report will show you where rows are. On any individual domain, like if you look at condition, you could see the population of specific fields. Another way to do this is what's called Achilles heel. So there's an Achilles heel report that comes up, and that will raise issues if it sees stuff that it thinks is weird. And the group that manages, it's like the thankless kind of tool within Achilles heel, all the quality checks that they put in. It's not often that we add new ones, but we do. They continue to add them. There are, I mean, some of the warnings, people get worried like, oh, I have warnings. Don't worry about having warnings. Like there's an interesting example. We have what's called a zombie check. A zombie check tells you if something happens to people who should be dead, right? They're dead, we have a record that they died, and then later something happens. That's weird. Although we've been informed that in some European countries, autopsies are recorded as part of the medical record, and therefore something happened after death. We have things where we check to see if things happened before birth, but now we have intrauterine operations. So these birth and death concepts are fuzzy. Anyway, so that report would also tell you if it sees a field that has not been populated, that it currently checks to see that it should. The other way is data print. I made a poster. There's data print. It's a cool way to visualize your whole CDM. If you don't have data in a particular table, it shows you. And plug. Any other questions? Okay. So continuing down this architecture stack, after you've accessed your standardized CDM data, you can see that you're right. There's lots of ways to leverage the web API. Arachne is a demo that will be done later today. You will see another tool that directly uses the API, not Atlas. It goes to the API and is able to leverage it. You can run your studies, as I mentioned, from within R, leveraging cohort definitions or concept set definitions from within the web API. You can do a variety of things through that or directly against your CDMs, right? The web API provides a set of services, but there's nothing saying that, there's nothing that says that within the work you do developing things within the OHDSI stack that you have to talk to the web API, okay? And I have some examples that I'll show you later where you could develop neat, novel things and it has nothing to do with the web API, it's just leveraging the data model and R packages. The other thing that I'm trying to point out here is that I don't consider the source data completely outside of the architecture. I think it's something we have to acknowledge, respect, and understand how it plays a role. And specifically when we're looking at the source data, you'll see that the web API is not talking to your source data ever. But things like the vocabulary do play a part in that data transformation process. It's not something that everybody has to deal with or understand necessarily, but it is important to realize that the vocabulary itself will change the way your data maps. As vocabularies change, your mappings may change. A recent change in, I forget which vocabulary, changed anemia from a condition to a measurement, right? And so that changes the way you could identify patients in a cohort, right? So it's like those vocabulary changes, everything has an impact on the way you do things. When you generate a data, when you convert a data set from your native source to your CDM, the version of the vocabulary that you use plays a role in that. So it is a major part of the way the architecture operates. So just something to call out and make sure that everyone's aware of. Any questions about the overall architecture? We've talked about Achilles. I've talked about this. This starts to get to why the architecture is relevant, right? So as I mentioned earlier on, the early mistakes I made in working with these data sets was having to rewrite everything I did for each data set every time. So the architecture is supposed to enable you to have better efficiencies in doing studies. Running your analysis across multiple sources. In my environment, when we're working, we can go and run a particular study across 12 databases at once and do so with a level of comfort because we understand that the vocabulary and the mapping and the CDMs and all that stuff has been thought out to the point where we're leveraging it all in order to be efficient in doing our study in a consistent way across data sets from around the world. So it's the goal, right? We're generating evidence using this. We don't necessarily focus on the fact that there's a Java REST API somewhere in the middle. I've talked about this a little, but I have a separate slide just to make sure it's clear because this is one of the questions I get most often. The data architecture, there is wiki documentation on this. I wrote it because I got yelled at enough times that I hadn't. But there are a few different schemas within our architecture. Again, I've mentioned them some already, but just want to call it out so no one yells at me anymore. There's the OHDSI schema, or that configuration database. There's your CDM schema, or the patient-level data. And there's a results schema, which is a read-write schema that is in your database that's created for things like the Achilles results table. The CDM schema is your read-only patient-level data set. It is the case, even in my environment, and in most environments, that everyone deploys their web API and their tool set where the CDM schema and the result schema are the same. So DBO, public, whatever it is. But there are environments where they have more stringent requirements around read-write access, so you can have them completely separated. Not completely separated. They have to be on the same platform, right? So think about it as a server. If you have a server with your databases, your CDM schema and your result schema must coexist. They can't be distributed across two different servers. Sorry, you have a question.
Yeah. One is there a list of the tables in those different schemas somewhere? And
clearly, I should have paid that man. So there is not a list of all of the tables. And in fact, I know that some people have experienced the pain of starting up Web API and trying to do things and finding that some table is missing. So specifically, what ends up being missing? This thing we use called Flyway manages the OHDSI schema, that configuration database. But it does not manage the results schema. And in fact, there isn't anything that does. In documentation for different features, you will see often a script that lists the tables you need to create to support different analytics. And so, you know, when you run Achilles, it'll create the Achilles results table. But for like incidence rates, there are tables that are required at in the results schema that don't automatically get created. There is not currently a list somewhere that I could point you at a single document that tells you all the tables that are required in the results schema.
And then, my second question was around data in flight, encryption of data in flight and at rest. Has there been any discussion around, you know, encrypting the services that are being transmitted? Or
so Web API can run under HTTPS. Outside of that, you're really dealing with a security issue in your local environment, right? So if you are enabling access to your databases to your SAS programmers or your R programmers, you're on your own there in terms of how they're connecting to these databases from a security perspective. From within the Web API, you can run it under HTTPS, and we do. So anything that's moving over that channel is encrypted.
Is there a configuration that needs to be set up for that, or?
I don't actually think there's anything in the API itself that you have to toggle a flag for. That's just coming in whatever container you're using and how you're deploying it. I'm not positive if there's not like a settings file you have to say, because you have to specify what your endpoint is. But in that case, as long as wherever you're hosting the WAR supports HTTPS, you just have to enable that within Atlas to say, please use HTTPS when you connect to the Web API. So in that, it would just be the configuration of where you point Atlas to what Web API endpoint.
Yes. I was just going to say, if you ever redo this slide, it just seems the fact that it doesn't say vocabulary anywhere.
You're right. There is a vocabulary schema. You just took away a minute of our break.
Right. Have one built within,
yeah.
Included CDM as well.
No, that's a great point. There is also a vocabulary schema.
If you ever redo this.
If I ever redo it. Ever.
But there is a problem with separating the vocabulary schema.
So you don't separate the vocabulary schema, but there is a vocabulary schema. So you can define it in some of the aspects of analysis that get run, like where your vocabulary sits. But very specifically, the CDM schema itself. This is one of the reasons I didn't put it there. The CDM schema itself contains the vocabulary tables. So I've worked with people where they're having issues with Achilles, for example, where none of their reports will render. And the reason is that when they're loading up statistics, one of the things that the Web API does is it queries both your results schema and the vocabulary. In this case, it assumes your CDM schema for the list of concepts so it could put the names of the diseases or drugs on the report. And they haven't deployed the vocabulary tables, that schema, into their CDM. It is a requirement that the vocabulary tables coexist within any CDM database.
SQL Server, those are actually separate databases, little DBOs. And that might be a little bit confusing. Postgres, their schemas within one database, and then you go to SQL Server, they're separate databases. Sorry.
Okay. Any other questions? Yes.
Still confused about the what tables are part of the flyaway result schema and the Odyssey schema.
So Flyway only manages the Odyssey schema.
Odyssey schema. So talking about these two tables, cohort table and cohort definition table. Cohort definition table has all the information, especially the JSON specifications of a cohort build process, I think. And the cohort table has the subject ID, start date, end date, the results information. So going by that logic, the cohort table is a result schema, and the cohort definition would become an Odyssey schema?
So you're touching on a particular pain point. Originally, when they developed the CDM, they had a cohort and a cohort definition table in the CDM schema. When we developed the web API, one of the things we realized is that we don't want our cohort definitions stored in our CDMs. The reason we don't want them there is because we want to reuse our definitions across all of our CDMs. So we created a cohort definition table in the Odyssey schema. There still is a cohort definition table, if I remember correctly, in the CDM specification. It is not used by Atlas or the web API. One of the things that's bad about this is there's a cohort definition ID that appears in the cohort table, which you accurately put in the result schema of a specific CDM that has the cohort definition ID, the person ID, the cohort start date, and cohort end date. That is specific to the CDM because that person is specific to that data source. That cohort definition ID lives in isolation in that database. There is nowhere that has the name of that cohort in your CDM itself. That name only exists back in the configuration database, the Odyssey schema. That's another thing that people will use the web API within an R environment to do is like, could I look up the name of what cohort 7 is?
Right. So thinking this is the follow-up question to this. So some people deploy Atlas using two DBMS. One is the Netezza, another one is the Postgres.
Yep.
The Postgres has the Odyssey schema.
Yes.
And the Netezza has the result schema.
Yes.
So the insert from the cohort build process, the generate process, should go into the result schema.
Yes.
But the Odyssey schema is here.
Yes.
So if cohort table has been deployed here,
the cohort table, so the cohort table should, there may be a cohort table in the Odyssey schema. We don't use that. If you have a table showing up there, that's just antiquity.
okay,
But it is not used. The only place so when we generate a cohort, specifically what happens is we load a cohort definition from the Odyssey schema into the web API. The web API uses logic in there to convert a JSON specification to an Odyssey SQL or an ODysSQL formatted SQL statement. It then uses SQL render and translate to translate it to the dialect. It hands it off to Spring Batch, the job manager, and says, please execute this query against this source. We connect to the underlying CDM database. We run that query. The end of that query does an insert into the cohort table of the specific CDM you were talking to. All right, so why don't we take a 15-minute break? We'll be here to answer questions if you have them, and we'll pick back up at 11:15.